Hey guys, welcome back to week 2, module 2. We're going to go over actually an algebra concept to start with. We're going to review perfect square trinomials, and this is all going to come back around to circles. So a perfect square trinomial is a 3-term polynomial that is the factor of a binomial multiplied by itself. Or I think, let's say the product of a binomial multiplied by itself. All right, so if we look at this first example, x minus 4 squared is not a perfect square trinomial, but it will create one. So remember, x minus 4 squared, that's the same as x minus 4 times x minus 4. We cannot distribute that exponent of 2 over both terms. So if you get like x squared minus 16 or plus 16 or something, we can't do it that way, but instead we could distribute each term of the first binomial to each term of the second, and sometimes we call that foiling. So when I multiply my first two terms, I get x squared. When I multiply my outer two terms, I get a negative 4x. My inner terms give me a negative 4x, and then my last terms give me a positive 16. So I could clean this up and say x squared minus 8x plus 16. All right, so that is a perfect square trinomial. And before we try to generalize some of its properties, what I would love for you to do is pause the video for a second and work out these other 4 examples out here to the right. Pause the video, try that, and then when you're done, I will work them out. All right, so I just paused my own video and worked these out. So all 4, or really all 5 of these examples are perfect square trinomials. So let's look at what they all have in common. So first of all, for all of these, the first and last terms are always positive. And additionally, the first and last terms are always perfect squares. So let's see what patterns we can pick up on. So x squared and 16 are both positive and perfect squares. So are x squared and 1, x squared and 4, x squared and 9, x squared and 25. And then the middle term can be either positive or negative, the second term. So we have a negative 8x, and that negative I can see corresponds to the negative in the original binomial. Over here we have a positive 2x, and this was addition, a negative 4x, and we had a subtraction, positive 6x from addition, and positive 10x from addition. So you might also notice that the number that is in the original binomial, so x plus 5, for example, when we square that 5 squared is 25. 3 squared is 9. 2 squared is 4, and so on. So these are not coincidences. This is just the structure of a perfect square trinomial. So all perfect square trinomials could be written in the following form. So like if I had some binomial a plus b squared, I would get a squared plus 2ab plus b squared. So that middle term is this first term from the binomial times the second term from the binomial times 2. So if I look at, for example, this 6x, that is x times 3 times 2 to get the 6x. Alternately, if we had subtraction there, the only thing that changes is the sign of the second term. So it just becomes negative. The third term, again, is always positive. I messed up my exponent. Okay, well, my eraser's not working. That should be a 2. All right, so that's a review of just what is a perfect square trinomial. This next part, completing the square, this is just how we basically create a perfect perfect square trinomial. And you did this in Algebra 1, but that was a while ago. So when we say complete the square, we mean find a term that makes the polynomial a perfect square trinomial. And it's not that hard because all the ones we're going to do today have a quadratic term that has a coefficient of 1. So I'm working with 1x squared, not like 4x squared, for example. So if we go back to that structure, I'm going to use addition. So we said a squared plus 2ab plus b squared, and that's the same as in factored form, a plus b squared. So if I look at that, my x squared, that's like my a squared. So I'm going to think of like x as being this a here. And then I know this term has to be 2ab. And then my last term is going to be b squared. So if I take this 10x and I think of like 10x has to be 2 times x times some other number that we're calling b. Well, if I divide 10x by 2x, what I get is 5. So 5 must be that number b. So when I square that, if b equals 5, b squared equals 25. So the number that completes this is 25. Now, I don't ever write all that stuff out when I'm doing this. That's a lot of writing. So here's what I would think of instead. If we are completing the square, we know our task is to make a perfect square trinomial. I'm going to make one that I don't think shows up on here. I'm going to do x squared plus, I'm trying to think of a good one. Let's say x squared plus 40x plus something. So I'm going to go big with this one. All right, so if our goal is to complete the square, take this middle term, just drop the x, let's just take the coefficient and divide it by 2, so it gives us 20, and then square that number. So 20 squared is 400. So this would be a perfect square. All right, so let's work these out real fast and then we'll be done with this first video. All right, so if we're trying to complete the square, oops, we said we could take this middle term, divide it by 2, so divide the coefficient by 2, so 2 divided by 2 equals 1, and then square that. 1 squared is just 1. So the number 1 will complete the square and make it a perfect square trinomial. All right, I'm going to move to the right side, take my 4x, 4 divided by 2 is 2, 2 squared is 4, so that's going to be another 4. Over here, x squared minus 6x, take that negative 6. Negative 6 divided by 2 is negative 3, but negative 3 squared is positive 9. All right, I'm going to do the rest of these in my head. So negative 8 divided by 2 is negative 4. Negative 4 squared is positive 16. 10 divided by 2 is 5. 5 squared is 25. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. All right, so that's going to be the thing that comes up the most for our purpose. This is all going to come back around to circle equations. But we could also work backwards and find that middle term when we know the first term and the last term. So for example, if I work backwards, I'm going to take the square root of 81. So the square root of 81 is 9. And then I need to double that because this middle term is always twice the square root of the first and the last multiplied. So 9 times 2 would be 18. So that middle term would be 18x. All right, so over here, the square root of 49 is 7, but I'm going to double that. The middle term would then be 14x. Down here, the square root, I don't know why I'm going in this order. The square root of 64 is 8, but let's double that. That would make that 16x. And then lastly, the square root of 100 is 10, but don't forget to double that, and that would be 20 times x. All right, when you're done with these notes, you're going to have a quick check for understanding.